Implantology and Aesthetic Dentistry in Dubai. Please join me in welcoming Professor Philippe Tardieu.
Okay, thank you very much for your introduction, and good morning to you all. And I would like to congratulate you to be here this morning, on Friday morning at 9 o'clock. Congratulations. So I'm going to cover a topic today is proper segmentation to proper objectives. Why? Because the topic is complicated. Because you have a lot of product on the market and you don't know exactly what you should use and how you should use this. So I'm going to make a kind of recollection on how is working the adhesion. I will cover the principle of adhesions. I will not be too much technical because I want this lecture to be really practical. I want you to be allowed to apply what I'm talking about tomorrow when you come back to your clinic. So there are several problems. You need to bond the restoration on different materials. First, enamel. What is enamel? And how should we bond on enamel? Can we bond enamel like it is, or should we treat the enamel, and how to treat it? Dentin. Dentin is difficult to understand. Dentin is almost like bone. What is dentin? How do we treat dentin? How should we bond dentin? And then ceramic. What is ceramic? I send a plastic cast to my dental lab technician and I receive a ceramic. What is this ceramic? How many families of ceramics you have? How do you bond them? Is there any difference in between all these so-called ceramics, which are not ceramics in fact? And how do we bond them? And finally, how do we bond crowns, metal crowns, and veneers? So how can you do all these things? And I'll finish with a few cases. So principle of adhesions. Adhesions has been deeply changed the way we are making dentistry, because adhesion has been moving from macro retention to nano retention. This means that when you are trying a zirconia crown over a tooth, it's not stable. But when you are trying a metal crown on a tooth, it is stable. So how can you stabilize and how can you bond something with no friction? So let's go over this and let me try to explain to you how it's working. To accomplish adhesion, the first principle is that the two substrate you are trying to adhere a restoration onto a tooth, in between there must be a very close contact. Close means as small as a nanometer. It's 10 power to minus 9. So you can read all the articles from Jean-François Roulet, publications on that. It's very clear about what is adhesion. So if you have two material like the solid 1 and the solid 2, I have two pieces of wood and I want to make them adhere together. I put one on top of the other. Will this adhere? No. Why? Because there is a space in between this and this. And this space, even if you do not see it, is really appearing. So you have only small forces making the adhesion and not enough forces to make your prosthesis adhere on the tooth. So you have two solutions for that. The first solution is to wet the surface. How can you wet the surface? You need to wet the surface, and this is based on the calculation of this angle. When the contact angle is high, there is no adhesion. When the contact angle is low, there is adhesion. Okay? This is what we call the wetability. Adhesiveness is poor on this side. Adhesiveness is good on that side. Wetability is poor. Wetability is good. Solid surface free energy is low, and this is high. So you need to wet. For that, you need to go to the people who are selling these wetting products and try to change the surface. which is a hydrophilic surface, into a hydrophobic surface, or vice versa. So this is what we call the Young equation, if you want to know more about this. So on a normal surface, okay, this angle is like this, and if you increase this angle, then this will be hyperhydrophobic surface. It will push what you call the bonding agent or the wetting product outside of the surface. The second way to increase the adhesion is to increase the surface which is in contact with the tooth. So if you take two glass plates and you put them in contact with a drop of water in between, you will not be able to push them out, okay? You can slide them, but you can pull them out, okay? Why? Because you have been creating strong adhesion, not only based on the wetability, but also based on the fact that the surface has been extended. So what and how can we extend that? If you take a crown like this, and you are going to make a preparation, this is an extended surface. This is a limited surface. So in some cases, when you go to the so-called veneer, you can include more of the veneer trimming material to go at the back of the contact point or at the back like this. So you will increase the surface which is going to be used for bonding. So this is important to have in mind. What you need to do, increase the wetability and increase the surface in contact. Let's talk about enamel. I know you know all about enamel, but I'm going to point out some issue about enamel. Enamel is, as you know, the best mineralized tissue of the body. And due to this, is it good to bond or not? We don't know. It consists of 95% of inorganic structure, hydroxyapatite. But the organic part consists of soluble and insoluble protein and few carbohydrates and lipids. So there is a part of the enamel which is organic too. Most of the water is bound to the crystal as hydration layer. Okay? So you have crystals and you have water in these crystals. Only about 1/4 of the water is free in the organic component. 1/4 is free in the 5%, which is the organic component. And since Bonocore, 1955, we described the way and the method to bond enamel. We know how to bond enamel. And since that date, there are really few changes on that, since 1955. You have to know that if you want to bond something on enamel which is not treated, untreated enamel is a very low surface energy and is therefore inadequate for bonding. If you want to bond enamel like this, it does not work. You have to treat enamel. Untreated enamel is covered by a biofilm. Every surface you have in your body is covered by a biofilm. Okay, a living film consisting of glycopolysaccharide coming from the saliva. So you have to remove that. How are you going to remove this layer? It's very simple. You use a 37% phosphoric acid, and this will remove the biofilm and will etch the enamel surface, ending with an adequate surface for a good bonding. So the way to do since Bonocore, since 1955, is the same. We use phosphoric acid to treat the surface. When the surface is treated like this, we increase the surface, making micro gaps on the surface of the enamel, and then we are going to be able to bond to enamel. And the bond will be very strong. So let's talk about fluorides. Fluorides are found on the outer surface of the enamel. You have more fluorides outside than in the depth layers of enamel. So this means what? When you are treating a tooth, when we are trimming that tooth, okay, and you are trimming in a very shallow layer, you need to, and fluoroapatite are less soluble. Okay, so you need to use the fluoroapatite in